Hello, Joko Christian here, and in this video we're going to talk about executing and controlling part 2 in project management. The content of this video is compiled from Project Management Body of Knowledge PMBOK Guide, 6th edition, and various other sources. The learning objective is to understand the process of controlling processes in project time management, understanding the process of controlling processes in project cost management. As we all know that project management knowledge area have many different types, as some will be implemented in control phase and some will be implemented in control and execution phase. And the execution process and controlling process activity have different intensity when the project is undergo, as you can see from this graph. Now, this is the matrix of knowledge area and process groups. We'll be focusing on executing and monitoring controlling process groups. And we're going to talk, the first is about monitoring time management. In knowledge area of project time management, the processes in controlling process, you'll see in the part is in this execution, there is none. In monitoring and controlling, there are one process in project time management. The process itself is called control schedule. So the knowledge area is project time management in the controlling process. The project time management includes all the processes that require to accomplish timely completion of the project. The control schedule is the process of monitoring the status of the project to update the project progress and to manage change to schedule baseline. It is concerned with determining the current status, influence the factors that cause changes, and manage actual changes as they occur. There are a few idioms that related to project time management. We're going to talk about float, which divided into total float, free float, and project float. Total float is the amount of time an activity can be delayed without delaying the project end date or intermediary milestone. Free float is the amount of time an activity can be delayed without delaying the start of its successor, the next in line. Project float is the amount of time a project can be delayed without delaying the externally imposed project completion date. Using those three idioms, we're going to talk more about later. The control schedule itself have three phases, which mean from input until output, using tools and techniques. The input itself is project management plan, project schedule, project performance data, project calendar, schedule data, organizational process assets, using the tools and techniques to output accepted deliverables, change requests, work performance information, and project document updates. Let's talk about the control schedule inputs first. The project management plan is the output of plan schedule management process. Project schedule is the output of develop schedule process. Work performance data is the data that being outputted when the project is executing. And project calendar is the output of develop schedule process. Schedule data is the output of develop schedule process. And organizational process assets is the assets that can be used in the organizational to complete the projects. So the control schedule tools and techniques: performance reviews using trend analysis, critical path method CPM, critical chain method, earn value management, and using project management software, also using resource optimization techniques. modeling techniques, schedule compression, lead and lags, and scheduling tools. Modeling techniques usually use Gantt chart, and we are going to see some updates on the project, such as if we have the original schedule in the first, and we have a short duration using crashing method. You can see that the line here on the red timeline is somewhat more smaller, more faster. Or we can use overlap tasks or fast tracking, paralleling process that can be done. Crashing itself is increasing risk and result in rework because cost and schedule trade-off are analyzed to determine how to obtain the greatest amount of compression in the time essence for least incremental costs. Fast tracking is doing activity in parallel that would normally be done in sequence. So if the normal is after A, it's B, B then C. Now we're going to talk about A and B doing and can be done in parallel. Fast tracking often increases risk and results in rework. The output itself is work performance information, schedule forecasts, change requests, project management plan updates, which consists schedule baseline, schedule management plan, cost baseline, and then we have project document updates and organizational process assets updates. The second part is controlling cost management. Control costs is a process with the roots of project cost management knowledge areas. And the cost management itself is the process involved in estimating, budgeting, and controlling costs so that the project can be completed within the approved budget. Project managers must make sure their projects are well defined, have accurate time and cost estimates, have a realistic budget that they were involved in approving. To control costs means that we need to use monitoring techniques, and we will monitor the status of the project costs and managing the changes of the cost baseline, including monitoring cost performance to detect variance from the plan, analyzing positive and negative variances, the differences sometimes higher or lower, and how they affect the other control processes. Influencing the factors that create changes to authorize baseline, ensuring that all appropriate changes are recorded, preventing incorrect, inappropriate, or unauthorized changes, and informing the appropriate stakeholders of authorized changes. As usual, we have a phase from input using tools and techniques to deliver outputs. The input itself, 1. Project management plan, which is the output of plan cost management process. It has cost baseline, cost management plan. 2. Project funding requirements. It is the output of determined budget process. 3. Work performance indicator. We're going to use earned value management indicators. 4. Organizational process assets. The tools and techniques that can be used is earned value management, forecasting, to complete performance index, performance review, which consists of variance analysis, trend analysis, and earned value performance, reserve analysis, project management software. Here we're going to see the S-curve of planned value. We're going to use planned value or PV, and sometimes it is referred to budget cost of work scheduled or simply just budget. This is the part of approved total costs estimate planned to be spent on an activity during a given period. As you can see, this is the start project and this is the end project. The start phase and the end phase. here. And usually the graph will start from $0 or rupiahs here and sliding up, climbing up into the end project. So we are covering 100% budget. That is the plan. Now, there is another S-curve. It is the earned value, okay, or budgeted cost work performs, BCWP. It shows the project achievement and the percentage value of work that have been completed multiplied by the planned value. As you can see on the left graph, the blue graph is the PV graph. The red graph is the earned value graph. This is still the start project time and going to the end project time. Currently, we have a line indicating the position of the current time. Now, this is S-curve with AC or actual cost. Usually it's called actual cost of work performed. It is combined from execution and implementation costs and direct or indirect costs that incurred in executing activities during a given time period. So, as you can see, we have a black graph now, AC or ACVP. This is the actual cost. The blue graph is still the planned value. And then the red is the earned value. Okay, when we compare the earned value with the actual cost here, we have two time frames here. We'll just call the time frame of A and time frame of B. Because the project is over budget in time frame A. We can see that because you can see here the EV is lower than the AC. Okay, the earned value is lower than the actual cost. But on the B time period, the project cost is lower than the than the budget. It is called more efficient because EV is bigger than AC. The earned value is bigger than the actual costs. But we can see also that the project is behind schedule since the beginning because EV is lower than PV. Now, there are EVM formulas that you can use. This we can call cost variance, CV. CV is EV minus AC. Cost performance index, or CPI, is EV divided by AC. If the CPI, cost performance index, is lower than 1 or EV is lower than AC, it means the project is over budget. But if the CPI is larger than 1 or EV is bigger than AC, the project is efficient. There are slight notes in time control. In schedule variance, it's called SV. SV is the EV minus PV. And the schedule performance index, or SPI, is EV divided by PV. If the SPI is lower than 1 or EV is lower than PV, the project is behind schedule. If SPI is bigger than 1 or EV is larger than PV, the project is ahead of schedule. Now, the outputs of the control cost is cost variance, schedule variance, cost performance index, and schedule performance index. That is the work performance measurements. Also, as the output is budget forecasts, change requests, project management plan updates, which include cost baseline and cost management plan, organizational process assets updates, and project documents updates. Some other related idiom might be budget at completion. It is the budget project and the value of the project. We have work remaining. Work remaining means BAC minus EV. Funds remaining is BAC minus AC. And the two complete performance index, TCPI, is the work remaining divided by the funds remaining. Estimate at completion, or EAC, is based on the cost performance. EAC is AC plus work remaining divided by cost performance index. EAC based on the remaining budget is EAC equals AC plus work remaining. EAC based on the budget at completion, or overall budget and the cost performance, is EAC equals BAC divided by cost performance index, or EAC equals BAC divided by cost performance index multiplied by SPI. We only use the lower part here when the situation is very, very bad, or when CPI is lower than 1 and SPI is lower than 1. That's it for the 11th meeting. Thank you for watching this informational video. See you again next time. Bye-bye.